The converse to the alternate interior angles theorem, a proof. What is the converse to the alternate interior angles theorem? In Euclidean geometry, so named because it follows a set of propositions based on 4th century mathematician Euclid's 5 postulates, states that if two parallel lines are cut by a transversal, then both pairs of alternate interior angles are congruent. Before we begin our proof, this is a compendium of items we need to know beforehand. The Euclidean parallel postulate, which states, for every line L and for every point P that does not lie on L, there is exactly one line M such that P lies on M and M is parallel to L. The alternate interior angles theorem says that if L and L' are two lines cut by a transversal T in such a way that a pair of alternate interior angles is congruent, then L is parallel to L'. Now we're ready to begin our proof by contradiction. Given the diagram as labeled, assume the Euclidean parallel postulate holds. Let L be a line parallel to M, where T is a transversal and T intersects L at A and intersects M at B. Assume that angle 1 is not congruent to angle 7. Without loss of generality, suppose that the measure of angle 7 is greater than the measure of angle 1. Then, construct line K through A such that the angle formed by K and T, call it 9, is an alternate interior angle to angle 7. Then, K is parallel to M by alternate interior angles theorem. Now we have two lines through A that are parallel to M. This is a contradiction to the Euclidean parallel postulate. Therefore, line K must be line L, and angle 1 is congruent to angle 7. And so, if two parallel lines are cut by a transversal, then both pairs of alternate interior angles are congruent. Thanks for watching.